The broadcast is now starting. All attendees are in listen-only mode.
Hello and good afternoon or good morning, and welcome to this session on the reduced inventory obsolescence through FEFO and shelf life picking. We will start now with the webinar. So during this webinar, I will go through a number of topics. First, I'll have a short introduction about Boyum IT. Then a short presentation of Produmex WMS with a focus on GS1 compliance, a number of functions for regulated environments in food and life sciences, and some specific FEFO and shelf life settings. And then I'll give you a demo in which these settings are applied. Okay. So you probably all know Boyum IT. Boyum is a company that has been around since 1997 and headquartered in Denmark, with subsidiaries and sales offices around the world and a certified sub-partner since 2004. But currently, Boyum employs more than 140 employees internationally, and the company is 100% focused on sub-business one. Now here you see a number of highlights in the company history, from the start of the company in 1997 by Michael Boyum up to the current period, and a history of consecutive growth. And the most recent milestone in this context is the acquisition of Produmex in April 2018. Since this means that now the Produmex solution portfolio is now also part of the Boyum portfolio, and Produmex has brought to the Boyum portfolio a number of additional certified sub-business one add-on in the area of logistics and production management. Now, during this session, we will focus on the Produmex WMS solution, and particularly on the use of this solution in a food or life sciences environment, where specific first expired and first out and shelf life conditions apply. Now, it is important to note that Produmex WMS for sub-business one is fully based on the GS1 industry standards. So GS1 is the global standardization body in the supply and demand chain, and the most important standardization or standards that GS1 has issued are the GS1 identification keys, by which they are able to uniquely identify logistic units by means of the SACC, so the Serial Shipment Container Code, by means of which they are also able to uniquely identify products by the global trade item number, and also locations of companies or entities of companies through the global location number. Now, of course, apart from this, there is the GS1 barcodes, where we have the GS1 14 or the GTIN 14 for the identification of individual products, and the GS1 128 barcodes for the codification of additional information related to products, namely, for instance, the batch, the best before date, or the quantity. And apart from that, there is, of course, also the electronic communication. Much of the communication between supply chain partners in the supply chain now is organized around these standardized messages, like a dispatch advice or an advanced shipping notification. Now, if we have a look at a number of specific functions in Produmex WMS for regulated environments, meaning food and life sciences, we have the capability in Produmex WMS to manage products by batches, but combine that also with management of serialized items. We have then the management of use by, best before or expiry dates, and also the possibility to manage shelf life in purchase as well as in the sales process. Then, of course, there is the aspect of FEFO picking, so first expired, first out picking. And next to that, we also support other functions that are of importance in a regulated environments, like, for instance, zone types, by which we can organize conditioned storage, quality statuses, and the full batch traceability that we can achieve. Now, let's have a look first at a number of definitions in this respect, with respect to FEFO and shelf life. Now, there is the notion of the use by date, which is a concept that is all about safety and that is used on food that goes off quickly, such as meat products or ready prepared salads. Then we have the notion of the best before date, and this is a concept that is more about quality and not safety. So food will be safe to eat for some time after this date, but it may not be at its best anymore. And then we have the concept of expiration or expiry date, which refers to the date printed on the container of an item for sale, and especially in pharmaceuticals, after which the item can no longer be sold and should not be used. So this is also about safety, patient safety. Now, the concept of expiry date in Produmex WMS applies to all of these three options. Apart from that, we have then the concept of FEFO, which refers to the practice of picking and delivering products on a first expired, first out basis, to ensure that the oldest goods or the goods that expire first are exit from inventory the soonest, so that we do not stay with products that go past their expiry date in our inventory. And then there is the concept of shelf life, which is the length of time that a product may be stored without becoming unfit for use, unfit for consumption, or unfit for sale. So in other words, shelf life refers to whether a product should no longer be on a pantry shelf, which is unfit for use, or just no longer on a supermarket shelf, which means that it's unfit for sale but not yet unfit for use, or on a pharmacy shelf, which means that it's unfit for sale and also unfit for use. So if we look at the graphical representation at the bottom, the shelf life is the period that we count between the date of the goods receipt and the date of expiry or the end of the best before date of that product. So all the number of days between those two dates are defined as the shelf life. Now, let's have a look at the FEFO and the shelf life parameters that we can have in Produmex WMS. We have a number of settings in Produmex WMS at the level of the item master data extensions, where we can define whether or not a product has a best before date. There can be an automatic calculation of a best before date based on the settings per product. But this automatic calculation can be overruled if the item barcode contains a best before date. So if the supplier itself mentions in the product barcodes that are on the product the best before date, this will overrule the setting in Produmex WMS. And the best before date will determine which product will be picked and delivered first. And then we have the shelf life conditions that can be set, where we can define a shelf life for purchase, meaning this is the period that we require from a supplier that supplies a product to us, that he guarantees that the product will be still manageable on our shelves before it expires. And so that's a shelf life for purchase. And then we have the shelf life for sales, which means which is the number of days that we guarantee that the product can stay on the shelves of a customer of ours. And we can specify that either as a generic shelf life, so one that applies to all customers, but we can also use customer-specific shelf lives or even country-specific shelf lives. And the shelf life conditions will determine which best before date can be delivered to which customer or which country. So let's have a look now at how this is set up in Produmex WMS. So we'll first have a look at the organizational structure and a few settings that are important for FEFO picking. We will then have a look at a number of item master data extensions for shelf life management. And then I will take you through the inbound logistics and the outbound logistics process to show how the settings will affect these processes. So let's now dive into the system. So if we look at our system here, we have our sub-business one application in which we have the Produmex module, and on the other hand we have here the RF terminal on which we will do the inbound and outbound logistics operations in the warehouse. So let's first have a look at the organizational structure in Produmex. There we define per company the warehouses that we have in the warehouse. So these are the warehouses that are defined in sub-business one, and which can be either managed by Produmex or they can be not managed by Produmex. If they are managed by Produmex, this means that we can have a very detailed structure of this warehouse, or specific layout of the warehouse in which we can define elements such as shipping and receiving docks, so where we will process inbound and outbound logistics operations. We can have storage zones where we have here a picking zone where we will store products that we will use for fulfilling sales orders. And on these locations, we can define whether they are fixed for a specific product or whether they are open to contain whatever product. And so this is a location where we can store whatever product we want, and this is a location where we can only store a particular product, and for that product we can then give or define maximum and minimum quantities and replenishment quantities. Okay. So in this organizational structure, we not only define the layout of the warehouse, but we can also define a number of settings. For instance, a very important setting is the way that we will allocate stock to sales orders. And that, for that purpose, we have here a pick list proposal generator that will define how will the system allocate stock to an order. And here we see that we have in this case indicated that the stock needs to be ordered based on the FEFO principle. And so the system will have a look at the stock based on the criterion which stock will expire first and which is then the stock that I will allocate first to the sales order. So that is a very important aspect. Then we also have here the GS1 settings for the logistic units that we will process in our warehouse. So we have here the range of numbers that we can use to generate logistic unit numbers. Then we have here our reports, which we'll also see in the demonstration. So we have here defined a number of reports, and we have also associated these reports with specific print events. So here, for instance, we have a print event called reception of a new logistic unit. And when this print event occurs, my report 61, which is my goods receipt label, will be printed. So these are a number of settings that will define how the system will respond. Now let us have a look now at the a number of item master data settings that are relevant in this context. So if we go to our item master data and we look at the particular product here, we see, for instance, here that this is a product that is managed by batches, which means that when we receive or process this good, the system will require a batch number. We see here the item barcode, so the GS1 global trade item number for this product. And then we have a number of fields in the Produmex tab that will further detail the processing of this product. So here we have defined that this product has a best before date. So when we process this product, the system will require that a best before date is indicated. So also here we have indicated the storage condition. So this needs to be stored in the ambient temperature zone. That also will affect the way that we can process this product. And then we have here in the purchasing process, we have defined a shelf life for reception. So the shelf life for reception is set at 730 days. This means that from the moment that we receive the goods, the supplier has to guarantee that we will be able to manage this product on our shelves for at least 730 days, which is 2 years. So he has to guarantee a minimum shelf life of 2 years when he delivers a product to us. If this is not guaranteed, or if he supplies a product with a lower shelf life, we are able to refuse it and send it back to our supplier. So here we have also defined an expiry definition for reception. So here we can specify also what is the typical expiry date for this product. So this is a table that we can populate with all kinds of expiry definitions. But this can be overruled if we receive a product that has in its item barcode also the best before date. And here we have also specified that the default quality status for the reception of this product is quarantine. So when we receive this product, the system will automatically put it into quarantine. So this for the inbound logistics process. If we now look at the sales process, there we see that we have also defined a shelf life for delivery. And that shelf life for delivery is at this stage set to 230 days. So if we supply this product to a customer, we have to guarantee that from the moment that he receives it in his warehouse until the expiry date until we get to the expiry date, a minimum of 230 days have to be guaranteed. So this is the generic shelf life, but we can also make this more stringent. So for instance, here we can specify that for a particular customer, the shelf life is not 230 days, but it's 275 days. And this will mean that a product that we can deliver to particular customers, because they only have the generic shelf life conditions, will not be able to be supplied to this customer, because its expiry date will be sooner than the shelf life of this product. We will see how the system will process this. And we can also do this based on a country code. So in this case, we have indicated that if we export this product to the United Kingdom, the shelf life will not be 230 days, but it will be 360 days. And these data will be used by the system in calculating which products the system will allocate to which sales order. Okay, so let's now first process a purchasing order. So let's see if we have a purchase order here. Yes, or we can create a new purchase order. Yes, so we select our vendor. And we select our product. we select our product, and suppose that we order 1 full pallet of this product. Okay, so we add the purchase order. We have our purchase order here now, and as soon as the purchase order has been added, we can start the goods receipt process. So we go now to our RF terminal. We click on the purchasing button and on reception, and then we indicate that we're going to receive this product on our receiving dock 1. And we will do this based on the order. It's also possible to scan barcodes. So if there are barcodes on the logistic unit, the scanning the barcode will associate the product with the orders that we have open. We can also do container reception, so of multiple purchase orders, or even if we have no reference to a purchase order, we can do a so-called blind receipt. So here we will go through the order, and there we have the purchase order that we have just created. So now the system asks me whether I'm going to receive identical logistic units or no identical logistic units. So suppose that I would be receiving 5 pallets containing the same product of the same batch and the same best before date, then I could speed up the receiving process considerably by indicating that I'm receiving 5 identical logistic units. Now in this case it's a single logistic unit, so I click on this. I have no label currently, and then I can scan the product or select the product. So if I would scan a barcode here that would contain the product, the batch number, the best before date, and the quantity, all these data would be captured automatically by the system. Now in this, there is always the possibility to have a manual reception. So I click here on select the product. So this is the product that was ordered. The system now generates a batch number itself, as it is configured to do that. But here again, if there is a batch number in the barcode on the product itself, this will overrule this setting. And then we have the best before date. So this is compliant with the best before date or expiry date setting that we have set in the item master data. So it suggests here the best before date using this setting. And then we specify that we're receiving 1 pallet containing 50 trays. So the goods receipt process is finished now, and what the system will now do is it will generate the a goods receipt label containing the information that we have captured during the receiving process in human readable format and also in barcoded format. So what we get here is on the one hand the SSCC, so the unique identification of the logistic unit, and we also get here the GS1 128 barcode, which contains the identification of the global trade item number. So 02 indicates that this is the product. 15 indicates the best before date. 37 indicates the quantity. So we have got 50 trays containing 24 jars per tray, means 1200 jars. And here we have got the batch number. And so in this way, this product is uniquely identified. So if we now return to sub-business 1 and we go to our goods receipt and we click on goods receipt, you see here that we have the goods receipt that is booked of the 50 trays that are stored at our receiving dock, and that this is the logistic unit on which they are stored, and that they are currently set in the quality status code of quarantine. So we have the batch number here and the best before date. So all information that we have recorded during the goods receipt process is added to sub-business 1. Okay. So if we have a look now at our inventory report in Produmex for sub-business 1, and we look at our item. So we select our item here. Now we get a full overview of all the items that we have in store. of this item. We have also here an overview of all the batch numbers, of all the best before dates, the storage location, and also here the SECC. And so here you see all the unique logistic units on which these are stored. And here we have got the logistic unit that we have just received, and we see that it is in the quality status of quarantine. This means that at this stage, this product will not be able to be used for picking operations. So it will not be considered by the product. But from this inventory report, it is possible that a responsible person or a person who has the authorization can change the quality status of this product. So we can say, for instance, here we're going to change the quality status, and we're going to change the quality status to released. And if we do so, we have to give a reason. And here we could say we are clearing or releasing this product because it is QC cleared after analysis. And we can then change the status. And what you will now see is that we see that the product is now in the state of release, still at the receiving dock. And also the action of changing the quality status is logged in the traceability report. Okay? So at this moment, the system has generated a put away order because this product does not need to stay on the receiving dock. So we're going to put it away from our receiving dock 1. And here we've got the SECC. So we select the SECC, so we scan it or we enter the code. And then we ask for the system to suggest a location. So we can have the default location here. We can ask the system to propose an empty location, or we could put it somewhere else. So if we would put it at another location than the one for which it is reserved, and that location would not be open for that product, the system would inform us that this storage location is not allowed for the item. So in this way, we can also manage where a product is stored. Now let's assume, for instance, that we're going to put it at this location here, B0001. Okay, we have now moved it into that location, and if we refresh our inventory report, we see that this is currently registered also in the inventory report. So this is the inbound logistic process, in which you see that we have already registered a number of parameters that will be necessary or relevant for the further outbound logistics processing of this product. So if we now proceed to the outbound logistics process, there I have already created a number of sales orders. So I have here a sales order for this product for a customer in the UK. I have here a further sales order for this product for a customer with a more strict shelf life. And we have here also a sales order for a customer who has the normal or the generic shelf life conditions. So let's now see what this means. If we look back at our inventory report, based on the FEFO principle, the way that the system will allocate stock is based on the best before date. So normally the system will first pick from this best before date, then from this best before date, then from the next, and so on and so on. But in this case, there is an extra condition, namely that the system will also take into account the shelf life conditions. And you will see what the effect of that is. So if we now go to the Produmex tab and we look at the open sales orders in our warehouse, we see that we have indeed these 3 open sales orders, and from these sales orders we can now generate pick list proposals. So we have here now the the pick list proposals. And if we have a look at these pick list proposals, at this stage, the system has already allocated the stock to the pick list proposals. So if we open this one over here, you will see that the system has allocated the batch number of this product with a best before date of the 6th of April 2019. If we look at the next one, this is for a customer with a more strict shelf life. There we see that the system has not reserved the batch which will expire on the 6th of April of 2019, but it has reserved the batch that will expire on the 1st of June 2019. And if we go one further to our UK customer, where we have the most strict shelf life conditions, there you will see that even that is not fit for that customer. There the system will propose the batch that will expire on the 14th of September 2019. Okay, so we can now generate pick lists for these three pick list proposals. The moment that I generate a pick list, they will be released to the operator. So I have now my 3 pick lists, which I can consult here in my open document report. So here I have my 3 pick lists now, and so here they are. And so here you see the pick list, and again here the best before date is indicated. Okay, so for this customer we also have another pick list for another product. So we can, from this open document report, we can also close pick lists. So let's close this one so that we can keep only the 3 that I have just generated. What I've also done now is that I have here printed the item labels. So these are the item labels that are normally on the products when they are stored in the warehouse. So here you see an item label containing the GS1 128 barcode for the product chickpeas with the best before date of the 6th of April 2019. So you see that this is coded in the barcode. Here we have the product with the best before date of the 1st of June 2019, and here we have the product with the best before date of the 14th of September, or the 14th of September 2019. Now I have a small scanner attached to my computer, so when I do the picking, I will use the scanner to confirm which product that I will be scanning. Okay, so let's minimize this. So we're now going to the sales process, and we're going to the picking process. And here you see now the 3 pick lists that I have released. So let's start now first with the one for our UK customers. He tells me you need to go to this location, and there you need to pick 1 tray of this item, of this batch, and of this best before date. I'm not going to pick and pack. I'm just going to pick the product now onto a logistic carrier. Okay, I will put it in a carton. Then I select my location. And next, I need to scan the product. So what I will do now is I will scan the wrong barcode. So I will scan the barcode that is not with the right best before date. So if the system now tells me that I cannot pick from this batch number and best before date. So in this way, the system will assure that I picked the correct batch and best before date. So I click that now. Now it sees that it is correct. I click 1 tray, and the items are picked, and the system will now generate a shipping label, where it now specifies in the shipping label on the one hand here again, the unique identification of the logistic unit, and on the other hand, the barcode with the information about the product. So we have now assured that we deliver to our customer in the UK the product that complies with his shelf life conditions. Okay, so let's now proceed with the second one. Also there, if we pick it immediately onto a carton and select the location, also there, if we scan the wrong barcode, the system will not allow us to pick from that. Just a moment. So we now scan the wrong barcode, and the system again informed me that I cannot pick from this, so I need to scan the correct barcode, and then it allows me to proceed again. The items are picked, and again a new shipping label with a new logistic unit code and also indication of the product that I have scanned and picked. And then the final one, here again, also the same procedure. Put it in a carton, select the location, and scan the barcode. And if I now select the right barcode, he will allow me to proceed immediately. Okay, so I select one tray. Okay, and my third shipping label. So in this way, I have assured that I indeed have picked the correct products for the correct customer, delivering to them the best before dates that are compliant with their conditions. And if I now conclude the shipping process from my cross-dock based on a pick list, I have here now my pick lists. And with each pick list, I then scan the correct logistic unit that will ship to my customer. So now it will generate here the delivery note, and also on the delivery note, it is specified which batch of which best before date that we deliver to our customer. If we go to the next one, also loaded, adding the sales delivery note in sub-business 1, and producing again the delivery document specifying the batch and the best before date, and our final pick list with the same procedure. So here again also the delivery document. And if we look now in the sales delivery, we have now here the deliveries to each of the customer with the correct products that have been delivered to them. So this is the demonstration of the way that Produmex WMS manages FEFO and shelf life picking conditions. I hope this was instructive to you, and I am available through email if you have further questions in this respect. So my email is lvdp@boyumit.com. I would like to thank you for your attention, and I hope that I can see you again in a further session on Produmex WMS. Thank you again. Bye-bye.